gang, good morning. We're going to review some of our different multiplication models. And I want to start off by first reviewing the words and the headings. The paper you have in front of you. If you're at home, go ahead and start copying these problems down as we work them out. So you'll see in the first column it says expression. Every word or every problem in this column is an expression because it has no equal sign. When we go to the column to the right, we're going to create estimates. When we create estimates, we're going to find out about what our product should be, and when we do that, we use an equal sign. That equal sign makes what we wrote here an equation. The equal sign makes that different from what's on the left, where we have an expression. We're going to solve each estimate for the original expression. Then we're going to do the standard algorithm. That's probably what your mom and dad will be more comfortable with. They may not know how to do the other model. We're also going to do the expanded form model, where we use our place value and we put it inside the bars, and we sometimes call that the area model. We're also kind of using the distributive property when we do this. So you can see that 4 times 451, I'm going to estimate that to 4 times 500. I'm going to round to the nearest hundred. When I do that and I get that estimate done, our product for the estimate is 4 times 5. That's going to be where I got that 20. And then I had 2 extra zeros. So I have 20 plus 2 zeros. So 4 times 500 is 2,000. So by the time we're done, 4 times 451 should get a product or an answer that's close to 2,000. Most of you guys are telling me you like the standard algorithm best. And when we use that, it's kind of the same idea of when we add. We start on the far right, we carry when we need to, and then we add up whatever we carried. Sorry, my alarm was going off on my watch. So in the next part, we see we did the expanded form or the area model. We took that first factor of 4, we set it in front, and then we're going to expand 451 using place value. I have a value of 400, a value of 50, a value of 1. When I add those back together, I get 451. I'm going to multiply in each box. 4 times 400, 1,600. 4 times 50, 200. 4 times 1, 4. Then I'm going to take each of these partial products and I'm going to add them up. So yes, I want to see you write them down. Shocking. 1,600, 200, 4. I pulled out those pieces and I added them up, and I should get the same product I got for the algorithm. If I get something different, I made a mistake and I need to fix that. Something's wrong, go back and fix it. Then I look, 1,804, is that close to 2,000? Is my product reasonable? Yeah, 1,804 is close to 2,000. I've probably done a nice job. All right, so let's do the next expression. It kind of got cut off in the copy machine. So it is 5 times 279. So the first thing we're going to do there is round the multiple digits. We're going to keep the 5 the same. The 5 factor is going to stay the same because it's a single digit. 279, I'm going to round to the nearest hundred. The 7, am I closer to 200 or 300? Yep, 300. So my estimate is 5 times 300. Writing this down with me. Back last week, you looked at the basic fact when you had zeros. So 5 times 3 is 15. But it's really 300, so I'm going to bring down those 2 zeros. So 5 groups of 300, 1,500. If I count by 3, 5 times, 3, 6, 9, 12, 15. I'm just adding those zeros on. Let's go over to the standard algorithm and see what our actual product is. So what I'm doing now is finding the answer to a multiplication problem. I'm going to start by going to the ones place, What is 9 times 5? 45. So the ones stays behind, and just like in addition, the tens gets carried over. So now I'm going to do 7 times 5. What is 7 times 5? Yep, 35 plus that 4 is going to give me 39. The 9 stays behind, and I carry the 3. Just like when we add, only we're multiplying. 2 times 5 is 10. Add up the 3, I get 13. I have nothing else to carry it over top of, so I'm just going to write the 13 down in the product area, the answer area. So right now I have 1,395. That is close to 1,500. So far it looks like my answers are reasonable. So now I'm going to clean this up a little bit so it's not so distracting. Oops, I did not want to do that. Oh well, you have it on your paper, right? So we're good to go. Was it 1395? I think so. I'm going to take the first factor, the single digit, that single digit factor, and I'm going to put it in the front of my area model. I'm going to break apart 279. That's my second factor. I'm breaking apart the multiple digits. It's 3 digits long. That's why I have 3 boxes. Place for the hundreds, the tens, and the ones. So I have 200 plus 70 plus 9. And fill this in with me. So when we talked about the distributive property this week, we talked about the fact that that 5 needs to be passed out with each of these pieces. So 5 times 200, 200, 400, 600, 800, 1,000. So 5 times 2 is 10, and then you have those 2 zeros, it is 1,000. Now I have 5 times 70. We can start by doing 5 times 7, it's 35. And then I have 1 0, so 5 times 70 is really 350. And the last one, in the ones, I've got that single digit. 5 times 9 is 45. So these are my partial products. I'm going to pull them all out. This is where you're going to be really careful in lining up your place value. Ones with ones, tens with tens, and so on. We talk about that all the time. That's being precise. I'm going to add like I always add. And do I have the same product for the algorithm and the area model? I sure do. Are they both reasonable with my 1,500? Yeah, they're close. We probably did them right. Let's try the next one. The two factors are 6 and 825. I'm going to keep my single digit factor the same. And then I want to round 825 to the front place value. I like to use the front because then I get lots of zeros, and when I get lots of zeros, it's easy to do in my head. And that's the whole goal of estimating. How can I make it easy so I don't have to write it down? You guys are all about not writing stuff down. So am I closer to 800 or 900? Yep, I'm closer to 800. I'm going to look at that basic fact. 6 times 8 is 48. And I have 2 zeros, so it's really 48 hundredths, or 4,800. That's my estimate. That's my about. That's my about. So now let's try the next one. 5 times 6 is 30. Carry my 3. 6 times 2 is 12. Plus 3, 15. 8 times 6 is 48, plus 1, and there's nothing to carry anymore. So 48, 49, I'm going to just write that 49 down. So I get 4,950 as my product using the standard algorithm. And yes, that is close to my estimate. I'm probably doing it right. So to do it in the expanded form, putting it in that area model, I'm going to take my first factor, 6, put it in the front of the model. I have a 3-digit number. That's why I have 3 boxes. And I'm going to expand that out. 800 plus 20 plus 5. Now I'm going to take that expanded, I'm going to distribute the 6 with each of those pieces. I'm going to use the 6 to multiply each piece. 6 times 8, 48, but I have 2 zeros. So it's 48 hundredths. Then 6 times 20. Well, 6 times 2 is 12. 1 0. 120. I can also count by 20s. Get your spirit fingers out. 20, 40, 60, 80, 100, 120. So then I'm going to go to the next part. 6 times 5 is 30. And then I have those partial products. So now I'm going to pull these partial products out, lining up my place value. I'm going to add it all up. And I'm going to get 4,950, which is the exact same thing I had in the standard algorithm. And they are both reasonable when I look at 4,800. Go ahead and turn the paper over. And let's try one more together. So the same headings, there are no changes in these problems. And I have a single factor of 3, so I'm going to leave that a 3. I have a 3-digit. I want to make lots of zeros, so I'm going to round to the nearest 100. I look at the number behind it. That tells me if I'm closer to 700 or do I need to go up to 800. Yep, you're right. I'm going to change that to 800, 5 or greater, add one more. So now I'm going to box this out. 3 times 8 is 24, and I have 2 zeros. So 3 times 800 is really 2,400. Now this is our estimate, so this is about what we should get when we finish multiplying using the next 2. So now we're in the standard algorithm. We're going to move straight up, starting in the back. 3 times 7 is 21. 5 times 3 is 15. Add the 2, so that's 17. 7 times 3 is 21. Add one more, that's 22. So 2,271. And yeah, that's pretty close to 2,400. So my answer is, or my product is reasonable. Last one in the area model. Again, take that single factor of 3, place it out front. You have a 3-digit factor, so that's why we have 3 boxes. And we're going to expand that to be 700 plus 50 plus 7. And then we're going to use the distributive to pass that out. 3 times 700. Well, 3 times 7 is 21. You have those 2 zeros, 21 hundredths. 3 times 50. Well, 3 times 5 is 15. And then add that 1 0. So 3 times 50 is 150. 50, 100, 150. So you can count up also and use your multiples. 3 times 7 is 21. So these are my partial products inside my model. I'm going to pull them out, line them up. And add them. And I get the exact same product, which is good. If I don't, I've made a mistake somewhere. So if this product is different from this one, then something's wrong, okay? That's why I put down at the bottom of the page, are all your products for the algorithm and expanded model all equal? You should be able to answer yes there. If you can't answer yes, you've made a mistake. Go back and fix something. Are they reasonable when compared to your estimate? Are they reasonable? Are they close together? If you answer no, then you've made a mistake somewhere. Fix it. You should be able to answer yes all the way through. So go ahead and try this last one, the last 2 on your own, and then you guys are off to work on your task list. So have a great day.